To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear grade 9 students. So today we are going to start the fresh new lesson in your grade 9 science syllabus. So this is some kind of a like day-to-day lesson. I mean, like, we can identify these things usually in our day-to-day life, right? I think you also have different kinds of experience with these lesson parts that we are about to discuss on today. So today within this lesson part, my dear children, we'll be studying about waves. Especially, we'll be studying about sound waves and about the light waves. Okay? About the sound waves and light waves. So my dear children, in 14th lesson of your grade 9 science syllabus, we'll be identifying or we'll be studying about the reflection and refraction of waves. Reflection and refraction of waves. Especially my dear children, we'll be discussing about sound waves and light waves. We'll be discussing about sound waves and light waves. Okay. So as you can see within the figure, right, you know that this activity, we carried out this activity in our grade 6 syllabus. We identified a special kind of a feature by using this instrument or by using this activity. We identified that light is going to travel on a straight line, and there's the light is composed of light rays, and several light rays are going to create a light beam, and so on. We're going to study about different kinds of things within this lesson part. Okay. However, more than that, I mean, like, when you take our grade 9 14th lesson, we'll be studying even more things related to the light lesson. We'll be studying about the reflection, about the refraction of light waves, and we'll be studying about what are the effects of reflection and refraction, how we can identify properties of images which is created because of the reflection. And in the same way, my dear children, we'll be discussing about sound as well. I think in grade 8, you have studied some related things to the sound. Okay. And also in grade 7, we studied several things related to the sound. In grade 6 also, we got a brief idea about the sound. So within this lesson part, we'll be discussing how to reflect sound waves. And because of reflection, what kind of effects are getting created within our environment, okay, because of the reflection of sound. So like that, we'll be discussing several things related to the lesson part within the reflection and refraction of waves. So stay with me till the end of the lesson. Like in the same way, we'll be discussing several extra questions and also questions in your textbook after finishing the lesson part. Right then, now let's head on to see what are the main topics that we are about to discuss on today. Okay. So first of all, my dear children, we'll be discussing about reflection of light rays. Reflection of light rays. So let me give you a simple kind of a brief regarding the reflection of light. In simple, reflection means bouncing back of light rays from one surface to another, right? I mean, like, not to another surface, but however, bouncing back of light rays by hitting on a certain surface to the same medium which it is coming from. Okay. So in simple, bouncing back of light rays. We'll be discussing several other things related to the reflection part when you go further with the lesson. Okay. So up to now, take us just simple brief idea about the reflection. Reflection is the process, right? It is the process which is going to bounce back light rays when struck on an object. Okay. So that is what do you mean by the reflection. So we'll be studying about reflection in detail within this lesson part, within the first and foremost topic. Okay. Then my dear children, we'll be head on to observe the sound. Okay. we'll be observing about sound. And over there also we'll be discussing about reflection of sound waves. Then effects which are going to create because of the reflection of sound waves. Okay. Then my dear children, within the third one, right, the final topic, we'll be discussing about refraction of light. Refraction is some kind of a different, it's a fresh new topic that you are going to study within this lesson part for the first time. Okay, for the first time you are going to study this thing, right? So let me introduce you what do you mean by this refraction. Actually, now when the density of a material is going to change, you know what do you mean by the density, right? In simple we can say that it's the mass contained within unit volume. Okay, so when change in the density of transparent materials, it should be transparent. Okay, so when change in the density of transparent materials, light is going to travel through that transparent material, but however, because of change in the density, sometimes the speed of the light rays are getting somewhat reduced. So for an observer like us, we will be able to observe that phenomena as a bending, right? As a bending of a light ray. The light ray is like going to bend and travel. Okay. So this phenomena is the one which is referred as the refraction, the bending of light rays. Actually, that is going to happen because of change in the speed of light when traveling from one transparent medium to another. These things are also referred as optic mediums. Okay, optic mediums. So when a light ray is going to travel from one media to another, right, because of change in their optic properties, because of change in their densities, what will happen? Light ray is getting slow down. Their speed is getting somewhat reduced. So this reduction of speed of light rays is observed to be as bending for us. Okay. So this bending process of light rays is referred as the refraction. So we'll be studying about the refraction process when you go further with the lesson part. So I have just given you a brief. What do you mean by the refraction? Okay. So this is the refraction of light. So we'll be studying about these main three topics within this lesson part, my dear children, right? So at the end of the lesson, we'll be discussing about the questions related to your textbook in details, right? Then my dear children, we'll be discussing several extra questions related to your lesson part over here, the refraction and the reflection of light and sound. Okay, right then. So now it's time to see our first and foremost topic, which is the reflection of light. Reflection of light. Okay, now before we are going to study about the reflection, we'll identify the special properties of light rays. Okay, now in here, light is a very important form of energy for man. Let us briefly recall what we have learned about light in grade 6 and 7. So you have studied several things in grade 6 and 7 regarding light. We discussed about sources of light. Then we discussed about luminous and non-luminous objects. We discussed about features of light. We discussed that light is a source of energy. So first of all, we are going to recall several properties of light. Okay, so here, according to the activities given, what are the conclusions you can make regarding the characteristics of light? So here, different activities are given like this, and you have to write down the conclusion over here. So if within the first one, a torch is directed towards a white color sheet. As you can see here now, light is going to travel on a straight line as a light ray within this, right? So within this activity, we can identify that light is composed of light rays and light is also going to travel on a straight line. Okay, this is the first and foremost activity which is given. Within this activity, we can identify that feature, my dear children. light is composed of light rays, and these things are traveling on a straight line. Okay, so we can write down the conclusion. Light is composed of light rays. So let's write down our conclusion. Light is made with light rays and transmit along a straight line. Okay, light is made with light rays and transmit along a straight line. Okay, however, my dear children, when you observe in this activity, we won't be able to we can't tell that light is going to travel on a straight line by using this activity, as a straightforward conclusion. Okay, we won't be able to give it as a straightforward conclusion. But however, according to our visibility, we can see that the light is traveling, or light ray is passing at a straight line. However, in order to get even more a better conclusion, we can carry out the second activity which is given over here. So here, my dear children, we are going to observe from this corner, and there are three, see, as you can see here, there are three cardboard sheets with a hole, right, with a hole. So here it should be hole. In your textbook also there is a small bit of a problem. Hole, H-O-L-E, not W-H-O-L-E, okay? So hole. So there is a hole in here, three cardboard sheets. There are three cardboard sheets over here. And there is a hole in the same straight line, okay? That means when you keep these cardboards one on another, right, the hole is on a same point. Right? The hole is on a same point. Now what you have to do, you have to paste these things by using clay or else any other kind of a material, and you have to fix those things in a same straight line, like according to the given diagram, right, on a tabletop or any other surface, right? Now what you have to do, you have to place a candle at the far end like this. Then you have to observe from this end. Now you know that if the three holes are on a straight line, then without any problem, you can see the flame of the candle. You can see the flame of the candle without any problem. Now what do you have to do? You have to push this end, right, or else one of these cardboard towards a different direction by using a finger or any other. Now what will happen? As you can see here, clearly within the figure, light rays which are passing from the candle is now not coming towards our eye, because, my dear children, we are changing the position of one certain hole. Okay, we are changing the position of one certain hole. By doing this activity, we can come into a wonderful conclusion. The conclusion is somewhat obvious in here, not like in the previous one. Okay, just for our observation in the previous one, we can see that the light is passing on a straight line, but however, within this activity, we can confirm it even more. So, my dear children, within this activity, we can conclude that without any hesitation, we can conclude that light is going to pass on a straight line, right? That's why when you are moving this cardboard, you can't observe the candle light. If it is curving down, then definitely you can observe the light. However, it's not getting curved down, it's traveling on a straight line. So, my dear children, when you move it like this, the holes will not align, so therefore you won't be able to observe the candlelight. Okay, you won't be able to observe the candlelight because of that, right? So this is the second activity then. So here, straightforward, we can say that the light is going to travel on a straight line without any trouble. Okay, so here our conclusion would be light travels on a straight line. Okay, light travels on a straight line. I'll write the observation as well for your convenience. So when moving the cardboard, candlelight cannot be observed. Right? This is our observation. When moving the cardboard, candlelight cannot be observed because the light is going to travel on a straight line. So this is the final conclusion that we can take. So within brackets, my dear children, I have included the observation as well. Okay, right then. The next one, there is a laser torch over here and we are directing that laser torch towards a plane mirror. So here the light ray which is directed towards the plane mirror is going to change the direction and travel. Can you see over here? This is the direction which the light ray is going to come. This is the plane mirror. Now upon hitting on the plane mirror, light ray is going to travel like this. So what has happened here, my dear children? Here you can clearly observe that the light rays, when it is going to hit on a certain surface, it's going to change the direction and travel. This change of direction of a particular light ray is referred as the reflection of light. So here light ray comes and hit on a certain surface and travel to a different direction. This is what do you mean by the reflection. So within this activity, we can say that the light can be reflected when they are directed towards a certain surface. Okay, light rays are getting reflected when directed towards a certain surface. Reflection means change of direction. Okay, reflection means change of direction when struck on an object. Okay, right. So here we'll write down the process of reflection then. Light rays are reflected. Light rays are reflected to a different direction right? Light rays are reflected to a different direction when struck on a surface. When struck on a surface. Okay, so light rays are reflected to a different direction when struck on a surface. When light rays are going to struck on a surface, the direction is going to change. By changing the direction, the light rays are going to travel. This is the process which is referred as the reflection. Okay, bouncing back of light rays when struck on a certain object, right? Okay, so these are the three main properties that we have identified earlier, right, in our grades 6, 7, okay? In our grades 6 and 7, we have studied these properties of light. So these are the main properties that we have identified in our earlier grades. Okay then. Now let's head on to see what are the new ones that we are about to discuss on today. So light is composed of very thin light rays which travel in straight lines. Light travels through a vacuum or a transparent medium in straight lines and reflects when strikes on a reflecting surface. So the other thing is, my dear children, usually each and every object is going to reflect light. Okay? Any object in the world is going to reflect light. Are there any objects that cannot reflect light then in our universe? Of course, there is. This kind of a body is referred as a black body. Okay, this is for your extra knowledge. A type of a body which can't reflect light is referred as a black body. So within our universe, we can observe these things. These are the ones which are referred as black holes. So over there, all the light rays are getting absorbed into it and they are not getting reflected back. Black bodies. Other than that, each and every component in our universe is going to reflect at least 0.1% of light rays. Okay? So each and every object within our planet Earth is going to reflect some amount of light at least. Okay? So here, usually to reflect light, we are going to use a good reflective surface. In simple, it's a mirror. So we are using mirrors to reflect light rays. Because of the smoothness of the mirror surface and the high reflective surface, the reflection can be clearly observed within a plane mirror. Without any trouble, we can clearly observe the reflection of light within a plane mirror. That's why it is given as a mirror over here. Okay? But remember that we can reflect light by using any kind of a surface. The issue is that, okay, issue means actually how we can observe object is, I think within the second lesson, when we are discussing about the structure of eye and ear, I think you have studied how we can observe a certain object. Light rays should come and hit on that particular object, and that light rays should come to our eye. By that way, we can observe that particular object. So each and every object which you observe in our environment or in your environment is going to reflect light. That's why we can observe those things. Otherwise, we won't be able to observe. Okay? So my dear children, remember each and every object within our planet Earth is going to reflect. Otherwise, we won't be able to observe that thing. Okay? Definitely those things are going to reflect light. That's why we can observe those things. If not, we won't be able to observe because our eyes are not interacting with that thing. Okay? Right then. So these are the main things that we studied in the earlier grades. Within this point, you can observe those things. What is that? Light is composed of light rays. Okay. Then those things are going to travel on a straight line. It is going to travel through a medium, through any kind of a transparent medium, right? Vacuum is a certain kind of a medium like that. Vacuum means, my dear children, without even a drop of a gas, without even a molecule of gas, 100% empty surface, 100% empty space can be referred as a vacuum. Like the space, outer space. In outer space, there is not even gas particles. There are not, the whole space is 100% empty. There is nothing in it. So that kind of a space is referred as a vacuum. Okay, so light is going to travel even through a vacuum. You know that solar rays or light rays from sun is coming towards planet Earth without any trouble. So the gap between Earth and the sun is entirely a vacuum. However, the light rays are coming through it. So light rays can travel through transparent medium and also through a vacuum as well. Then, my dear children, we studied that light can be reflected when those things are going to struck on a certain surface. In simple, we can say that through when light rays are going to hit on a certain reflective surface, then it's going to reflect, bounce back. Okay. Alright then. So here you are given with a certain point. Now here the main lesson that we are going to study is the reflection of light. No. This is the main subtopic we are going to study now. So now we are heading to see what is this reflection process. You already know what is the reflection, right? So bouncing back of light ray into the same medium. Now my dear children, we are like somewhat enhancing the definition for the reflection process. Here in the earlier grades, we haven't studied about that medium thing. Okay. Now we are going to go somewhat advanced. I mean, like here in the earlier grades, we have studied that bouncing back of light rays, right, is the one which is referred as the reflection. However, now in here within grade 9, there's a special thing given, medium. So what do you mean by that? Medium means, my dear children, any kind of a matter, right? Any kind of a transparent matter. You know that light is going to travel through transparent matter, no? So any kind of transparent matter can be referred as a medium. So you know that we are living in our environment right now. So our environment is covered with gases. However, we won't be able to observe those things, even though we know that our environment is covered with gases. So light is going to travel through these gases, right? These gases. So gas is the one which is medium, which is behaving as the medium for the transmission of light rays in our atmosphere. Okay. So you know that when you observe like this, when you go towards a pond and when you observe like this, you can see the fish who are living inside the water. Okay, up to a certain level, we can observe the fish. So over there, the light is going to pass through water. So water is the medium. Sometimes, my dear children, okay, through glass surface. Let's imagine that you're at a window pane, near a window pane, right? Now close the window pane and observe like this. So if it is a transparent one, you can clearly observe the outer environment through the glass surface. Now over there, the light is going to come, or light is going to transmit through the air medium, that means in our atmosphere, and towards your eye through the transparent glass medium. Now over there, it's a solid. So any kind of a matter, right, any kind of a matter or else a vacuum can be simply referred as a medium. Okay, can be simply referred as a medium. This is a medium, my dear children. This is the definition for medium. It's really simple, not that much of a big deal. So now within our environment, we are living on an air medium because we need oxygen gas to survive. So our atmosphere is going to provide it. So we are living in air medium. Fish, they are living in water medium. They are living within the water, no? So they are living in a water medium. Okay, medium means that, right? So light can travel through these transparent media. Okay, so when you take the vacuum also, light can travel even through vacuum, right? So here, bouncing back of light rays into the same medium, and now within this figure, we are directing a laser light to the mirror over there. Then when we are directing it, we are in the air medium, that means in our atmosphere. So when we are directing this thing, the light rays are going to hit on the certain surface and travel back to a different direction. However, that reflected light ray is also traveling within our atmosphere or in our air medium. So bouncing back of light rays into the same medium when struck on a certain object or when strikes on a certain surface. This is the one which is referred as the reflection of light. It's pretty much simple, my dear children. There's no that much of a big deal over here, right? The only thing which is getting deferred over here is the medium thing. Okay, so I have explained you what do you mean by the medium of the living medium that we are in. Okay, so medium means the environment which is going to cover or which is filled with which is being filled with. Okay, it can be any kind of a solid, liquid, or else a gas. So light is going to travel through these medium. Okay, sometimes it's going to struck on an object and travel to the same medium which it is going to come from. Okay, this process is the one which is referred as the reflection. Right then, so I hope that you got a good idea about the reflection process, right? Okay then. So here, now my dear children, we are going to do a simple bit of an activity. Okay, we are going to do a simple bit of an activity over here. So here it is given reflection of light by a plane mirror. Now we are going to use a plane mirror surface. You know that plane mirrors are the ones which can reflect light very well. Plane mirrors can reflect more amount of light rays. Okay, so when you take a certain plane mirror, actual plane mirrors can reflect light up to 99%. Very small percentage is getting light absorbed by the plane mirror. Yes, the plane mirror is not going to reflect almost every light ray. Some amount of light rays are getting absorbed into the plane mirror surface. Okay, some amount of light rays, not all, but however, maximum percentage of light rays are getting reflected by a smooth plane mirror surface. That's why in order to identify the process of reflection, we are using a plane mirror. So within this activity, my dear children, we are going to also use a plane mirror to identify the reflection process. So here, reflection by a plane mirror. This is our topic. So to identify how the light is going to reflect from a plane mirror, we are going to carry out this activity. Okay, we are going to carry out this activity. Now to do this activity, you will be needing these materials, my dear children. Okay, we will be needing a plane mirror for sure, right? Plane mirror. Definitely will be needing a plane mirror. Then A4 sheets. A4 sheet. Laser beam. Okay, laser beam. Then pair of scissors. Right, pair of scissors. Then my dear children, a ruler. So you know, my dear children, what this thing is. This is the protractor. So you know that protractors are used to measure the angles. Okay, so within this activity, we'll be needing to measure some angles as well. Okay, so we'll carry out the activity. Okay, so then by that way, you would know how to measure, or you will get to know how to measure the angles and what are the kinds of angles that we are going to measure over there. Okay, right. So the protractor. Then to draw the ray diagram or the pathway which the light rays are going to travel, okay, we'll be needing a pencil. So these are the ones that you need. plain mirror A4 sheet or else a white color surface. Here when you are taking the surface, it should be we should be able to write down certain things. Okay, I mean, like, we should be able to draw, right, by using pencil and these instruments. So that's why I written over here as the A4 sheet, but however you can use any other different kinds of sheets for this thing. Okay, then a laser beam or else a laser torch. Then we'll be needing a pair of scissors. Then, my dear children, ruler and a protractor and a pencil, right? So these are the materials that you need to carry out this experiment. Now let's see how to do the experiment. So you are given with a figure over here. So within this figure, you can see how to carry out the experiment. See, it is given over here. Place the sheet of white paper on the table and place the plane mirror perpendicular to the paper using a stand. So you have to place the white color surface, I mean the white color A4 sheet. Then you have to place the plane mirror perpendicular to that paper using a stand. By using a certain stand, we can keep it. Okay, perpendicular. I mean, if this is the surface, then this should be the plane mirror. So over there, the angle should be 90 degrees like this. Okay, this is the white color surface. This should be the plane mirror. Like this, you have to keep the plane mirror and the white surface A4 sheet. Then draw the mirror line on the paper and direct a narrow inclined beam of light along the paper onto the mirror using the electrical torch or the laser torch. So what you have to do now, after placing it, you have to draw the line. You have to draw the line. Line means over here, my dear children, you have to draw the line of the plane mirror which you placed. Okay, you have to draw it. Then what do you have to do? You have to direct the laser beam or the torchlight towards the mirror. Rather than using a torch, my dear children, it's better to use a laser torch, because we can clearly identify how the light rays are going to travel after reflecting on a certain surface. Okay, we can clearly identify it without any trouble. So that's why using a laser torch is somewhat convenient for this experiment. Okay, so here it is given. Draw the mirror line on the paper and direct an arrow inclined beam of light along the paper on the mirror using the electrical torch or the laser torch. Right. Then observe how the beam of light reflects from the mirror. Now you have to observe how it is going to reflect from the mirror. So as you can see, like this, it is going to reflect. Like this, it is going to reflect. See, this is the light ray which is coming and this is the one which is going after reflection. Okay, you can observe two different light rays like this. Okay, now let's head on to see what are the other contents. I mean, like, there's certain other kinds of methods too. As you can see, now we have directed it, but however we never took any angle. No, we never measured any angle. We haven't used our ruler, protractor, pencil. We haven't draw anything. No, so we have to draw something. That's why we use those equipments. So let's see how to get the diagram related to this reflection process right now. So trace the incident and reflected rays of the paper using the pencil and remove the mirror and complete the rays using the ruler. Now you have to trace these incident rays and the reflected ray. What do you mean by the incident ray? So this is the one which is referred as the incident ray, my dear children. Over here within the diagram, you can see the incident ray. This is the one which is referred as the incident ray. Why it is referred as the incident ray? Incident ray. Okay. Then This one is the one which is referred as this one, this particular light ray. This is the one which is referred as the reflected ray. Reflected ray. So, the light rays which are coming towards the reflective surface is referred as the incident ray. Light rays which are coming towards the reflective surface. That means light rays which you are going to direct towards as a reflective surface. This is the, right, this particular one is the one which is referred as the incident ray. The light ray which is going to bounce back or change the direction and travel. This particular light ray is the one which is referred as the reflected ray. So, incident ray, reflected ray. Okay? Incident ray, the reflected ray. So easy. Okay? So, the light ray which you are going to direct towards a certain surface in order to reflect, that's the incident ray. Light ray which is going to travel after the process of reflection, this is the reflected ray. Right. So, now what do you have to do? Trace the incident ray and reflected ray using the paper, using the pencil, on the paper using the pencil, and remove the mirror and complete the rays using the ruler. Now what do you have to do? Now you have to keep the top laser beam like this, and by using your pencil you have to mark how it is going to travel. Then you have to remove the plane mirror surface and you have to draw like what kind of a way or what is the pathway of reflected ray and the pathway of the incident ray. You have to draw it. Then what do you have to do? Construct the normal line to the plane mirror at the point of incidence. Now measure the angles at either sides of the normal line. What do you mean by the normal, my dear children? What is the normal line? So this is the one which is called as the normal line. This one over here. As you can see, it is indicated as a broken line. Over here, this one, can you see? This is the normal line. In simple, it is called as the normal. Okay, it is called as the normal. So, then we come across with another special point over here. Okay, so that's the point of incident. See, point of incidence or point of incident. All the things are correct. So, point of incidence or point of incident. What is that? It is also very simple, my dear children. What is that? That's the point where the reflection is going to happen. See, over here you can observe it. This is the point which is the reflection is going to happen. So, this is the one which is called as point of what? Point of incidence. Right? Point of incidence. This is the point of incidence, my dear children. Right? So, I'll mark that thing over from the other side, or else I'll write it like this in order to observe very clearly. So, point of incidence. So, I'll mark it. This is the point of incidence, right? The point of incidence, right? Then, my dear children, the normal. Normal is the perpendicular drawn to the mirror surface or the reflective surface to the point of incidence, okay, to the point of incidence, not to any other place. You have to, in simple, you have to draw a perpendicular line to the point of incidence, okay. You have to draw a perpendicular line to the point of incidence. It should be perpendicular to the mirror surface, okay. It should be perpendicular to the mirror surface. So to a point we can't draw a perpendicular line, no. However, the perpendicular line or the normal, it should pass through the point of incidence and it should be perpendicular to the mirror surface. So perpendicular drawn to the mirror surface at the point of incidence is the one which is referred as the normal. This is an imaginary line. I mean, like within a certain reflection, we won't be able to observe the normal, right? We won't be able to observe normal over there. In a reflection, in a normal day-to-day reflection, you can only observe the incidence ray and the reflected ray. That's it. Normal is an imaginary line that we are going to draw, right, after the reflection process. That's why it is named, or that is why it is given as a broken line over here. We won't be able to observe this thing, okay. So this is a line which we are going to draw by our own. So that's why it is mentioned by using broken lines, as you can see very clearly, right. So here this is the normal. Then, my dear children, you can observe two different angles at the either sides of the normal. The first angle, which is over here, that is referred as the angle of incidence or else incident angle in simple. Why it is called as the incidence angle? Because here, over here, this angle is the angle which is located between the normal and the incident ray. The angle which is located at the normal, between the normal and the incident ray, is referred as the angle of incidence. Okay, this is the one which is referred as the angle of incidence. Then at the other side, you can observe an angle which is created between the normal and the reflected ray. Okay, normal and the reflected ray. This particular angle is referred as the reflected angle or angle of reflection. Angle of reflection. Angle of reflection can be identified between the normal and the reflected ray. What is the normal? Normal is the imaginary line. It's not an actual line. Okay, we are going to draw it by our own. So it is the imaginary line which is perpendicular to the mirror surface. Okay, perpendicular to the mirror surface, and it is going to pass through the point of incidence. Okay, the perpendicular drawn to the mirror surface through the point of incidence is the normal. For each and every reflection, we have to draw the normal, my dear children. Okay, we have to draw it. We are the ones who are going to draw the normal. Okay, normal cannot be identified within a certain reflection which is going to happen in our environment. In order to get a certain relationship, in order to identify the laws of reflection, we are going to draw the normal and see what's going to happen. Okay, that's the whole point of drawing a normal over here. Right then, so what you have to do is very simple. Direct the torchlight or else the laser beam towards the plane mirror, then get the reflection, trace the reflected ray and the incident ray, then complete the ray diagram or else the pathway of light ray which is going to travel after hitting on the mirror surface, right? Then what do you have to do? To the point of incidence, draw a perpendicular to the mirror surface. Then you have to measure the two angles which is created between the normal and the incident ray and the normal and the reflected ray. Okay, so I'll mention the two angles over here. This one is referred as I, in simple I, and this is the R, I and R. So what is I and R? over here, let me write I. This is the angle of incidence. Angle of incidence, right? This is the angle of incidence. Then, my dear children, over here you can observe R. R is the angle of reflection. Angle of reflection. So, INR. So, I have marked INR over here. So, shall we? Okay, INR, you can observe it over here, right? Then this perpendicular line is the normal. This angle is the one which is referred as I, this one, and this is the R. Okay, so INR you can observe the angle of incidence and the angle of reflection. So what you have to do, you have to measure these angle of incidence and the angle of reflection. So this is how to conduct the activity, my dear children. Okay, right then. So now let's head on to the lab and we'll do this experiment and let's see what is going to happen with the two angles. So my dear children, within this activity, we're going to identify how does the light rays are going to behave during a reflection. So within this activity, I have used a mirror over here, a plane mirror, and I have fixed it by using a stand, and there is a white paper which is perpendicular to the mirror. As you can see, it is very perpendicular to the mirror surface, right? Even you can measure the perpendicularness by using the set square. So we'll be using this set square in order to draw out the perpendicular to the lines or the light rays which are going to reflect after when I'm going to direct this laser beam to the mirror. Okay, then after that, in order to complete the ray diagram, I'm going to use a ruler, and to measure the angles I have a protractor, right? I have a protractor. Then you know, we have to draw it, so I have a pencil with me and a laser box. So this laser box is going to direct a laser beam towards the mirror. Then we are going to draw the direction which the light ray is going to travel towards the mirror, and after the reflection we are going to mark the reflected ray also. Then after that we are going to draw out a perpendicular. Then from the perpendicular we are measuring the two angles which are at the either sides of the perpendicular. So this is our aim, my dear children, right? So now let's turn on the laser box like this. So as you can see here, it's getting reflected. So now we need to keep it like this in a steady position, right? Then after we have to draw these lines like this. As you can see here, it's very clear to us from here to here. This is the line which is coming towards the mirror, and this is the laser line which is coming after the reflection process. So we have to draw out those two lines, my dear children. Okay, then we have to use the set square and draw out a perpendicular to the point of reflection, right? Then what you have to do, you have to check the angles at the either sides of the two light rays. So this is our activity, my dear children, right? So you know that we have to do it in a somewhat darker kind of area, otherwise you won't be able to observe this thing very clearly, right? So I will low down the light rays, right, which is in the background. Then we'll continue the activity after that. So my dear children, now we have darkened the room, so it's time to conduct our activity then. So this is the light ray which is passing towards the mirror, and this is the light ray, this one is the light ray which is passing away from the mirror after the reflection. So first of all we have to draw the the straight line which is coming from the mirror surface. So we'll draw it like this. And the other thing is, when you are placing this thing, the mirror, always check whether it is perpendicular to the paper. Right? You can use the set square in order to check the perpendicular. Right? Now let's draw the line first. Right, now let's take the smaller ruler. I'll use the set square because it is somewhat difficult to use the longer ruler. But however, my dear children, when you are completing the ray diagram, you have to use the longer one, right? So we'll use the smaller one here just to mark out the line or the light ray which is going to reflect after the process of reflection or after meeting the mirror. Right, so my dear children, now it's time to draw out the two lines. So I'll keep the set square like this, and let's mark out the straight line. Right, now the line after the reflection. Okay, now let's draw the line once more. Okay, so we have marked the two lines, my dear children. Now let's take out the mirror and we'll complete the ray diagram. After that, then let's measure the angle between it after making a perpendicular. So my dear children, we have drawn the two straight lines. This is the straight line which is coming towards the mirror surface, and this is the straight line which is going after the reflection process. So now we'll take it out and we'll complete the ray diagram by using a ruler. And after drawing out a perpendicular, let's see what will happen to the two angles. So I'll turn off this thing. We'll take the paper. And now let's complete the ray diagram like this. So this is the light ray which is coming towards the mirror surface. This is the mirror surface, my dear children. So I'll draw some kind of a darker line in order to show that that's the covered area. This is the reflective area. Now let's keep the set square and we'll draw a perpendicular to this line. So when you are drawing the perpendicular, make sure this is in line with the horizontal axis like this. Okay, now let's draw the perpendicular. Right, now we have two angles, my dear children. Right, so this is the first angle and this is the second angle. Right, so there are two angles. Right, so my dear children, now let's draw out the two lines. So I have the two lines here with me. So let's draw the two lines. So this is the light ray which is coming. So we'll complete that into here. Here we go. In the other line, make sure that you complete it accurately. Right. So now this is the light ray which is coming towards the mirror, and this is the light ray which is going after the reflection. Now let's measure the two angles between the perpendicular, my dear children. So as you can see here, this is the 90-degree angle over here. So this is the other straight line which is coming from here. So from here 90 to 10, 20, exactly there is 30 degree of an angle between the perpendicular and the line which is coming towards the straight or the light ray which is coming towards the mirror. So there is a 1, 2, 30 degree angle. 30 degree angle. So I'll mark 30 degree here. Right? There's a 30 degree angle. Now let's head on to see the other side. As you can see here very clearly, once again from 90 to 1, 2, 3, that means 10, 20, 30. There are 30 units once again from here to here also, from the perpendicular to the light ray which is coming after the reflection. So once again there is 30 degrees over here. Right, so from this activity we can clearly observe that the angle between the perpendicular and the light ray which is coming towards the mirror and angle between the perpendicular and the light ray which is going after the reflection are equal to each other. Within this activity, it was 30 degrees each. 30 degrees each. So my dear children, the light rays which is coming towards the mirror, this light ray is referred as the incident ray. This is the incident ray. So the light ray which is going after the reflection process, or the bouncing back light ray is referred as light ray which was bounced back after hitting on the mirror surface is referred as the reflected ray. The imaginary line, this is not actually a line. We drew that line. There was no line over there when we are doing the activity. As you can see, it was very clear to us that the laser beam just going to hit the mirror and reflect it after hitting the mirror. However, there was no any perpendicular in it. But I have driven the perpendicular so that to check what will happen to the two angles at the sides. So this is an imaginary line which we drew in order to check the conditions which is going to happen during a reflection. So this line which we drew which is going to be perpendicular to the point of reflection is referred as the normal. So this is called as the normal. The incident ray, light ray which is coming towards the mirror, and this is the reflected ray. So this is the mirror surface, my dear children. So the other condition is that always this normal is perpendicular to the mirror surface. Always remember, it is a perpendicular line to the mirror surface. Right then, so from this activity we can clearly observe that the angle between normal and the incident ray is equal to the angle between normal and the reflected ray. These two angles are specially called as the angle of incident and the angle of reflection, my dear children. So you will be learning about these things quite more. Right then, so this is our activity, my dear children. So we have finalized the activity. From this activity, we can come into a conclusion that the incident angle is equal to the angle of reflection during a plane mirror reflection. Right then, so once again, let's head on to the classroom and we'll write down our observations and conclusions. Right, my dear children. So we carried out the experiment. And over there, you can observe a certain bit of a relationship. We can identify that the angle of incidence is getting equal to the angle of reflection. Okay, so that's the observation that we can clearly get. Okay, So by doing that activity, my dear children, we can come into a conclusion that angle of reflection is getting equal to the angle of incidence. Okay, so that is our final conclusion from the activity. So we'll write down our observations then. So first of all, the observations are quite simple. Angles which measured are getting equal. Angles which measured are getting equal. So what is the conclusion from that? We can say that angle of incidence is equal to angle of reflection angle of incidence is equal to angle of reflection during a reflection. Right, so observations are quite simple. The angles which measured are getting equal. So you know that we have to measure the angles at the either sides of the normal. Over the method we discussed it. Okay, then my dear children, our conclusion is quite simple. During a reflection, right, during a reflection, angle of incidence is equal to angle of reflection. This is our final conclusion from the activity then. Okay, right. So now let's head on to see what are the other contents in our lesson. So a diagram that shows the way the rays are traveling is known as a ray diagram. Now the diagram which we drew over there within our laboratory, that diagram is referred as the ray diagram, my dear children. That is referred as the ray diagram. Why it is referred as the ray diagram? Because over there we are representing how the light rays are going to travel after the reflection process by using a certain diagram. So that diagram is referred as the ray diagram. Usually in a reflection, right, we are going to draw and show how the reflection is going to happen by using the ray diagram. Okay, then in the activity what you have constructed is a ray diagram to show the reflection of a light ray from a plane mirror after its incidence. And now over there within our activity we represented how the light ray is going to travel after the process of reflection. Okay, so that particular diagram which we drew over there is the one which is referred as the ray diagram for this particular activity. Okay, so in a usual ray diagram, my dear children, we can observe these properties. This is related to a reflection. Okay, so these are the properties or the features that we can observe. First of all, we can observe the light ray which is coming towards the plane mirror surface. Usually when we are drawing a plane mirror surface in a ray diagram, my dear children, we'll be using this kind of a straight line, this kind of a straight surface. Okay, you can use the ruler to draw it. So you use a straight line like this. Then my dear children, what we are going to do is we are going to dark one particular region of this straight line like this. So you know that in a plane mirror, one particular surface is darkened and the other surface is the reflective surface. From the reflective surface, the reflection is going to happen. So in the same way, within this straight line, over here you can observe the reflective surface. So this is the reflective surface. Okay, this is the reflective surface. This area is the dark surface. So that's why we are going to dark it like this. So over here also you can observe the plane mirror, the darker surface. Now this surface is the one which is going to do the reflection, which is the reflective surface. And now the light ray which is coming towards the reflective surface, that's the incident ray. We can observe the incident ray in a ray diagram. Then the light ray which is passing after the process of reflection is referred as the reflecting ray or the reflected ray. Then my dear children, definitely you have to draw the normal. Normal is the straight line or the imaginary line, the perpendicular line to the mirror surface on which is passing through the point of incidence. Okay. So this is the mirror surface. This is the normal line. Always it is perpendicular to each other. Remember, it is perpendicular to each other. Okay. And the other thing is that this normal line is drawn to the point of incidence. So these factors can be observed, or these features can be observed within a ray diagram. Incident ray, reflected ray, and the normal line. Okay. These are the ones which we can observe. Then the other thing is that, my dear children, the law of reflection. It's a law actually. We'll be identifying about this law when you go further with the lesson. It's a law, my dear children. What is the law? Within the activity also, we came into a conclusion, right, regarding that law. So that law is the angle of incidence is getting equal to the angle of reflection. That's the law. It's a law. It cannot be changed. Always the angle of incidence is getting equal to the angle of reflection. That's how a particular reflection is going to happen. So this is the one which is going, and the normal over here, and the two angles should be equal to each other. Okay. We are going to draw the reflected ray, we are going to draw the incident ray, and always when you draw the perpendicular line to the mirror surface to the point of incidence, the angle at either sides of the particular perpendicular line, which is called as the normal, is getting equal to each other. In each and every reflection you can observe it. Okay, right. So these are the features that we can observe within a ray diagram. So this particular thing is the one which is referred as the ray diagram for a certain reflection. Right then. So once again you are given with the definitions for each and everything. Let's see. The ray that falls on the mirror is called the incident ray. Once again, the incident ray, right? Incident ray is the light ray which is going to fall towards the mirror, or else that is the ray which is coming towards the reflective surface. Next one, the point where incident ray contacts with the mirror is the point of incidence. So once again, the point of incidence, you know that that's the point which the incident ray is going to hit on the mirror surface, or else that is the point of reflection. That's the point of reflection. So point where the incident ray contacts the mirror is the point of incidence. Next one, the ray that reflects away from the mirror is known as the reflecting ray or the reflected ray. Ray that reflects away from the mirror, right? Ray that reflects away from the mirror. This is the reflecting ray. The perpendicular line drawn to the mirror at the point of incidence is the normal or the normal line. Then, my dear children, angle between incident ray and the normal is the angle of incidence. Then, angle between the reflected ray and the normal line is called the angle of reflection. Angle of incidence and the angle of reflection. Right? So these are the main features or the factors that we can identify within a certain ray diagram. Okay. Usually for a reflection, we can draw and show how the light rays are going to reflect, and that particular diagram is the one which is referred as the ray diagram. So in a ray diagram, you can observe these factors. Let me recall what are the things once more. The ray which is falling onto the mirror is the incident ray. The point where the incident ray contact with the mirror or point where the reflection is going to occur is referred as the point of incidence. Then the ray which is going to reflect away from the mirror, that is known as the reflecting ray. Then the perpendicular line drawn to the mirror at the point of incidence is the normal or the normal line. Then the angle between incident ray and the normal is called the incident angle or the angle of incidence. The angle between reflected ray and the normal line is called as the angle of reflection or the reflected angle. So these are the things that we have identified mainly within a ray diagram. Okay, so I hope that you got a good idea about the ray diagram, my dear children. And the first and foremost law that we have identified, the angle of reflection is getting equal to the angle of incidence. Okay, we'll be doing even more activities and experiments in order to show that law, my dear children. Okay, right then. So within this part of I'm going to finish up our first chapter. Okay, by doing this part, I'm going to finish up the first chapter. Within the second chapter, we'll be discussing several other more activities regarding the plane mirror reflections and about the laws of reflection, my dear children. Okay, so I'm going to meet you with the second chapter to discuss those experiments and activities.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.